Hey everybody, it's Chief Meteorologist Brad Panovich. It's Monday, May 11th. I cannot believe, but this is our 45th edition. 45. We've done weather schools here at WCNC. We're going to try to keep these going through the end of the month as best we can. Today's topic, though, is my topic, which is great. We get to talk about the greenhouse effect. Now, the greenhouse effect is something you hear a lot about, but a lot of people don't really understand. When you talk about greenhouse and the planet and temperatures, well, we're going to talk about some of the things that go into the greenhouse effect and some experiments you can try at home to kind of test some of these principles of how gases in the atmosphere trap heat on our planet. It's really important. Our planet would not be inhabitable if we did not have this, but it also is a problem if we have too much or too little of the greenhouse effect. It can cause wild swings in our temperatures and our climate and cause big time issues. So the first thing you need to talk about is the principle of our air. Our air is really what insulates the planet. You got to think about this as like the jacket for Earth. Nitrogen makes up a big chunk of our atmosphere. Only 21% of our atmosphere is made up of oxygen. That's what we need. And that 1% of other stuff, while it's small, has a really big impact on the Earth. 78% of our atmosphere, nitrogen, 21% oxygen. You'd think, man, those other little gases don't mean a whole lot, but they are really, really important to our atmosphere. So the air is really important. And it isn't just air, because typically there's tiny particles in the air as well. We call those aerosols. That's like dust or pollen this time of year. You've seen a ton of that are picked up and blown around. Soot, smoke, other things that you see that actually looks like pollution. That's particulate matter. That's the stuff that you can actually see. Most gases are invisible. So the stuff you see is typically little particles. Now, those are important, believe it or not, to weather, because every little particle is actually a condensation nuclei for a raindrop or snowflake or even clouds to seed on. Sometimes dust, pollen, and even salt from the ocean that gets suspended is actually a very important part of our weather. Now, it's important for living things. Obviously, we breathe it in and we exhale. Great thing about plants is they need the opposite of what we need. They produce oxygen and they take in carbon dioxide. We take in oxygen and push out carbon dioxide. So we've got this great relationship between plants and us, and all mammals really, that need oxygen. Now, carbon dioxide in the air can be good and bad. We need it, or our temperature of our planet would not be ideal to live on. But just like having too thick of a blanket, it can actually cause you to get hot, too hot. You want some of that heat to escape. And if you've ever been in the car on a hot sunny day, boy, you don't want to be in there very long, because your car is basically a greenhouse. If the heat can't get out, it gets super hot. The air also holds water, which is really important. Water vapor, you don't always see it, but you feel it. That's the mugginess that we have in the atmosphere. And believe it or not, water vapor is actually a bigger greenhouse gas than even carbon dioxide. So carbon dioxide causes things to warm up. You put moisture into the air, that increases the water vapor content, that causes it to get even warmer. So you can see kind of the cycle that you get into. Now, air changes obviously as you go up. We talked a lot about this in air pressure. As you go up in altitude, there's less air above our head, so there's less air pressure. So the heavier air, or the more air is down at the ground. It's where we feel the highest pressures. And it's a protective cushion. The ozone layer blocks out a lot of the harmful rays. And there's also a lot of protective properties of the air that cushions our planet. So it keeps us warm and it protects us. I always think of it like a jacket on a cold winter day. It blocks the wind, but also keeps in some of the warmth. It's life. There's all kinds of things in the air. There's organisms, there's pollen, microbes are flying all over the place. Sometimes things are long distances in the air. It's a really important part of what we do as far as human beings. So let's talk first. We jumped ahead here. I'm going to go back to the greenhouse effect. So we've got some great illustrations here. Now, most people think the greenhouse effect, we're in a greenhouse. No, that's not really the way it works. The greenhouse is actually the atmosphere. So a greenhouse, even on a cold day, can trap a lot of heat inside. So the atmospheric gases that we just talked about are really key to this. Now, some of those gases, and I have some characters to kind of illustrate this. We've got water vapor, which is H2O. We've got carbon dioxide, which is two biggest greenhouse gases right there. Those are our 1 and 2 greenhouse gases, water vapor and carbon dioxide. There are other greenhouse gases, methane and ozone. Now, remember, ozone's way up in the atmosphere. It blocks out harmful rays, but it does absorb some heat. So it is technically a greenhouse gas. Methane is actually produced by a lot of decomposing materials. If you've ever been near a swamp or near a landfill, you might see the flares. A lot of landfills in Charlotte have these vents that vent the methane. And actually, I used to play golf at Renaissance, and you couldn't have open flame or anything. But all these warning signs: please don't have open flames anywhere near this area, because there was methane always being produced from all the decomposing garbage. Also, nitrous oxide and chlorofluorocarbons. Now, CFCs are something that are only man-made. All these other elements do occur naturally in our planet. CFCs are something man-made. And that's actually what deteriorated the ozone layer. And there's still some around, but there's very few being produced now because they basically worldwide. Now, why are these gases important? Well, the sun's incoming radiation hits the Earth's surface and it wants to bounce back up. But a lot is trapped or is absorbed by clouds, by the ground. But because of the ozone and because of all those greenhouse gases, a lot gets trapped in the lowest part of the atmosphere called the troposphere. And the Earth is about 60 degrees. If we didn't have this atmosphere, we would freeze. So it's a really important part of our lives. Without it, it would be a big problem. Now, the more CO2, the more greenhouse gases we put in, methane, nitrous oxide, ozone, even water vapor, the more evaporation occurs, the lower atmosphere gets warmer and warmer. And over time, that heat can build. It gets stored in the oceans, gets stored in the atmosphere, and it can have detrimental effects to our climate, just like having not enough CO2 could have detrimental impacts. Most of the huge shifts in our climate over our history, we can see in the geologic record, were because of swings in CO2. Now, a lot of this happened naturally because CO2 was released from the earth or from the oceans, and it created wild swings in CO2. Our recent rise in CO2 is mainly because we've taken it out of the ground and burned it and put it into the atmosphere through fossil fuels. That's why you're hearing so much about the greenhouse effect and climate change or global warming, is because the amount of CO2 that's stored in the ground is not in the ground anymore. It's been released into the atmosphere at a rate much quicker than would happen naturally. So it's causing things to warm up quickly. Now, one way you can experiment with how the greenhouse gas effect works, or the greenhouse effect works, is you can actually do some experiments at home. So I put together a quick little video on some things you can do at home that can kind of illustrate this. And you can test to see how much of an impact some of these gases have on keeping things warm. And I'm going to show it to you right now, because some of these are really cool, but they take some time, and I'll put all the supplies out there so you can see. So next, it's time to do some cool experiments. Now, these are going to take time, so I couldn't do them all live. And certainly you could do this over a couple days. There's a couple different ways to test the greenhouse effect. Now, one way you can do it is pretty cool, is get some jars. These are pickle jars. I'm going to put water in here, and nothing in here. But you can see I labeled them. I actually labeled this water plus CO2. I'm going to label this just plain water. And I'm just going to put air in here. So this is labeled air. Now, you're going to need a thermometer. This is the hard part about the times we're in. Thermometers are hard to come by. You get infrared thermometers, meat thermometers. Get any thermometer you want. In fact, if you could put a small thermometer inside here and tape it up against the side, it makes it easier to observe. So what we're going to do is, I've got lids or duct tape. You can always do stuff with duct tape. So what we're going to do is, we've got the lids. I'm going to first take some sample measurements of the temperature here. So we're going to shoot that into there. And I've got 63.3 for that water. I've got 66.4 for that water. And inside the empty jar, it's a little bit warmer, 66.6. So they're all relatively the same. They're going to vary a little bit, but keep them at room temperature in the shade. And you can do that. Next thing you need to do, you're going to need your parents' help for this. This is Alka-Seltzer. If you don't know what this is, these are if you have upset tummy, or you have, antacid buildup. But one of the cool things about these, basically effervescent tabs or Alka-Seltzer is, when you put it in water, it fizzes, and that fizzle bubbles are actually made up of carbon dioxide. So what I'm going to do is drop 2 in here and close it up. And what we're hoping is that this will fill with carbon dioxide. So we'll take 2 in here, and it's pretty cool. I'm going to actually bring this closer to the camera so you can see, because it's kind of cool. This is fun just in and of itself. So you take the 2 tabs, see right there, drop them in there, and see the fizzing going on in there. So I got to seal this up because those bubbles are actually creating CO2. So I'm going to close it up, real tight. Now, if you can't close it up with the lid, duct tape will work, seal it up. But look at that. Isn't that cool? So the bubbles that are coming to the top are actually getting trapped up here. One of the cool things about doing duct tape over the top is you can actually see it expand a little bit. You could put a balloon here and it would fill up with CO2. That's another cool experiment. So this is just water. You know what we're going to do? Absolutely nothing. We're just going to seal it up. Okay. The next thing we're going to do is take our other air and seal it up as well. So now we've got 3 bottles here, or jars. This one's got water, but it's filling up with CO2 up here. That gas is going to get trapped in here. Here is just water, but remember, some of the water is evaporating, so we're going to have water vapor in here. And then this is just good old-fashioned air. The next thing you'd want to do, and this is where the time part comes into play, you can either take a light bulb and stick it near them, or a flashlight. Don't use LED because you want a little bit of heat. Or you could stick it out in the sun, but I would recommend if you stick it out in the sun, put white paper underneath them. Now, why am I putting white paper? Because I want sunlight reflected back in there and not to get the heat from like a black top or something else. So I would take basically some paper, lay it out, and put this in the sun for a little bit and watch to see how the temperature changes. Now, the key part here is you want the temperature of the air, not the water. So if you have thermometers in there, keep them out of the water. Put the thermometers on the side, and you'll see the difference that because of the CO2 in here, this air will get warmer because it's going to trap more of the sunlight coming into the jar. It can't get out. This will actually trap quite a bit of heat as well because of water vapor, and then just good old-fashioned air, probably going to stay the coolest. I'm just going to do this quickly to see if there's any change. We'll shoot it just at the air. 66.6, 66.1, and 66.5. So they're about the same. They're not going to change a lot. So take these, put them in the sun, and then you come back and check them later. So that's a great experiment to do. Another great experiment, which is super easy to do, is get your insulated Yetis or whatever insulated version you like, Arctic. There's a million versions. Your mom and dad probably have these. Now, everybody knows this keeps your drinks hot and keeps your drinks cold, depending on the time of year. This is a very simple principle of the greenhouse effect. I can't find anything more simpler than this. If you take boiling water, which is going to be at 212 degrees, dump it in both ones. The water temperature is going to be the same, okay? Take the lids on one, only close up one. Leave the lid open on that one. And then use your thermometer. You can use a meat thermometer with this one. Put it into the one without a lid after about 30 minutes, and put it into the lid, the one with the lid on it after 30 minutes, and see the temperature difference. You'll notice that because of the insulation or the trapping mechanism of this lid, it's going to keep this warmer. This is basically the greenhouse effect in your cup, okay? We're trapping the heat that's been placed in here. We're not introducing more heat at any point. We're just trapping it, and that's what happens with the greenhouse effect. The sunlight, the incoming solar radiation has not changed much over hundreds and hundreds of years. It fluctuates slightly, but it's really not changing all that much. What's causing warming is retrapping more of that heat inside, and that's basically what your Yeti cup does. So a couple experiments you can do at home. Leave these out for a while. These are fun you could do for a couple days in a row. Maybe just keep an eye on them and see how they warm up and cool down. The key part is to seal them up and have a good thermometer to measure the greenhouse effect. All right, so those experiments are great. And the cool thing about doing experiments like that take days, you can do it over and over again and keep track of it. One thing I would highly recommend is keep a log sheet. Get out your piece of paper. I think I have somewhere. There we go. I've got a little, notepad here, my WCNC notepad. Is maybe go check it every 30 minutes, every hour, every 2 hours, and just experiment. See like what type of gas I could trap into the bottle. Does it keep it warmer, cooler? Now remember, you don't want to introduce more heat to one jar versus the other. So that's why I said keep them in the sunlight. Use one light bulb. Use white. It's a really cool experiment to see how much heat can be trapped just by using gas. And other cool things you can look at for examples of the greenhouse effect: your car, obviously a real greenhouse, your house, everybody's windows. A lot of people, like my house, we have double pane windows. There's argon gas trapped in between. That gas helps trap heat. The cool thing about the greenhouse effect, and as well as windows, is visible light gets in, but the heat can't get back out. So it's a really cool principle. Our planet would not be what it is without the greenhouse effect, but it also tells you how it can get out of control or be too little. We've got this perfect balance that we need on our planet to keep things all the same. And when things get out of whack like that, that's where we run into problems. So hope you enjoyed today's weather school on the greenhouse effect. We will probably talk more about other parameters of climate change in the next couple of weeks. Some of the other things we're working on, and we've got several more weeks left, maybe one or two. Let's see, we're at number 45. But if you missed any of those 45, remember, you can go to WCNC.com or go to our YouTube channel. That's where I went. We've got a playlist. Every single one is there in chronological order. It's great. I had someone tweet at me last night asking about weather instruments. I said, oh, great, go to our weather school. It was episode whatever. I can't remember now. I think it was the first week or maybe the second week that we did weather instruments or thermometers. So go check that out. Weather school is every day at 1 p.m., but you don't have to watch it live. You can go back and watch it on YouTube. Have a great day, everybody. We'll be back tomorrow with weather school here at WCNC.